was what we're missing technology-wise? Stability. Actually, we developed very, very good equipment, long-lasting 10 years and so on. But what we can see is consistently preventing our customers from getting the full benefit of it is that it's a very, very sensitive system. Everything have to match. There's a little thing like too much water in the concrete, then the concrete is flowing too much. We have to stop and clean the system and so on. So operational stability is really something that we are working hard on. We can do certain things to improve that, but in the end, it always boils down to the skill level of the operators. And that means if you have the skillful people, it is still so that they maybe get 20 or 30% out of the productivity that they could if they were still. So therefore I'm saying operational ability. So if we could make the equipment less dependent on the operator skill, that would be beneficial, and we are trying to do that. We cannot succeed with doing it 100%, but to a certain extent we can do so. The way we do slabs, I could have shown a video of it. What we do is, the thinking is, anything that is vertical, you print. Anything that is horizontal, you cast. Okay? So, in line with the multifunctional construction printers, we are also developing a casting head, so that you have a printer, it can print the formwork for the slab, and then there will come a casting head, and that will run over with casting. So the only manual thing would be to placement of the reinforcement, unless you use steel fighters and you put them into the casting chair. But that's how we made it. You break the formwork. Tools that would be then, typically will done in sections, right? I have to say that if a building is just rectangular square, then probably it's cheaper and easier to just rely on precast.
Sure.
Because you have the hollow core structure, which is one of the few structures coming from precast that actually has been tried to be optimized, right? Because of that hollow core situation. But anything that has a shape, you can forget doing that. And so we are more competing with in situ cast laws than precast laws, I would say. So, yeah.
Thank you. More questions, observations, ideas? Alex, please.
Many questions. Thanks. This was fun. I liked how provocative you were.
That's good. I think it's nice. Alex from two Eindhoven.
Sorry, yeah. I don't know anything about concrete. The big pro is that I guess all you three make is sustainability and form freedom. That's what I get. But if I look at the buildings that you've printed or that your machine prints, then you hardly make use of the palm freedom, assuming you have round corners or something. But that's gets so special.
Remember, I don't have side, so my customers, that's what side is, right?
That's and many of the elements that you print, I mean, if you really would optimize for sustainability, then you could also pick a different material that is inherently less.
No. You can move them all, right? So the reason why we build the concrete is because it's so bloody cheap.
So picking an alternative material, yes, you can, which is more CO2 friendly, but it'll be double as expensive, and nobody wants to pay that. It's already too expensive as it is.
So is the problem sustainability, or is it costs, or is it
both? And automation, and it's true that a lot of the buildings that have been made so far has not taken full advantage of the design capabilities. But again, you have to change the world slowly. If you do something too radical, I could also show you something that was way more radical, right? That has been made with our technology. But people are fairly conservative, and the construction industry as such is conservative. That's the truth, because they need to make sure that things are not in 30 or 50 years. So typically you see more like a gradual change or an evolution than a revolution.
Yes, yeah. Do you believe that there is that at a certain point in time there will be a need for super radical form freedom in like the bigger share of
You can say that's what we did with the Kazan line. In order to achieve that full sustainability, we have to go to something louder.
but that's say for residential buildings or so. Just
Yeah, there is a limit to how little you can use. It depends on what we compare to. Compared to bricks, it's way more sustainable because you way less material and it's because it's much stronger. But it's still quite limited for each building. You know, we have to think about bigger building, data centers, warehouses, apartment buildings. Their structural optimization will provide popcorn. And I even the potential is also bigger.
yeah.
I'm thinking about the three presentations, and I have the feeling that we have to join forces. And let me explain you why. I mean, one of the things that for me was really fascinating, and I know that it is complex because you are all, Navid, maybe you are more in the academic side of it, but you are dealing very much with the fact that you are under market pressure. Henrik, you have to sell your machines, otherwise it collapses. And Michel, you need to also have your customers. I mean, it is very important. You say money talks, yeah. Okay. And one of the things that happens is that within this context, you still need to kind of find a way to develop an R&D and to develop the innovation out of it. One of my questions was actually, if it is indeed a moment where we see the 3D concrete printing technologies integrating global market and construction markets, we know that we need also to create reinforcement. Would it make sense in a multifunctional setup to have Michel's robot doing the reinforcement with his? No, okay, I know you do. No, but I'm interested to understand why not. Okay,
Because it's too slow.
because it is too slow.
It is super slow. Metal printing is so bloody slow. How much can you print per day? Something like this?
No, a lot more, but it's like that. Maybe a kilo per hour of days.
But you are moving from 2 months to 28 hours. How can you say that? It's too slow, but tomorrow it might be.
No. Metal printing has been around for 10, 15 years and or more even. And it's still bloody slow. It is just really slow.
And very expensive.
And very expensive. So no, yes,
It's very expensive.
you would no, the other, and this is one of the areas where we would like to see much more research. For instance, we can put steel fibers into our concrete, right? Which is a benefit for us because then we have the reinforcement done automatically, right? We don't have to, not we, but our customers don't have to go around the manual rebar and put it in, right? There's not that much research on that, on applying that to different buildings types and so on. You know, what we can do. We are even come that far now, together with DTU, of course, that we are x-raying the samples that we are printing, and then we are developing the nozzles so that we can align the fibers in the print direction. And actually, the first scanning, the x-ray scanning we did was really surprising because everybody, all of us, also DTU, also, we will see quite a fine alignment along the print direction. No, the fibers actually move like that. So if this is the print direction, the fibers move like that. So actually they did the opposite. They more or less aligned perpendicular, which was really a surprise.
That's what I said. That's what I said. And I'm not an engineer.
I'm also not into this. But anyway, so now we have redesigned the nozzle and we are getting the next test results. And I'm sure in the end we will get it. And that means that we will be able to dictate that the fibers are coming out in the print direction, which means that basically when the structural engineers does a calculation, they always apply a safety factor of 100% because they never know in what direction the fibers are in. Now, when we know which direction the fibers in, you can remove the 100% and you can use half of the amount of reinforcement, right? So the use of steel fibers, it basically directed steel fibers. Research in that direction we're super interested in.
I have a question. Anand Bentur from the Technion. you have mentioned that you are printing with concrete, and you were not so kind with regards to printing with mortar.
No.
And that's a question what I want to ask. If you are talking about optimization, topological optimization, and this is the area of Oded, which is here. Basically, if you think about, rather than having a volume of concrete, having the element built as a truss. And if you do that, you can save a lot of material, you can optimize the truss, and the fact that you have a mix which has a little more cement, 20, 30 cement, the overall,
And it's 10 times as expensive. 10 times.
not necessarily. Not
The commercial mortars that exist for 3D printing, called ready-mix by these mortars, they come in a bag. That means that everything comes in a bag. You just have to add water. Super convenient, super easy. Maximum particle size 2 millimeter. The issue is, in order to do that bag where you have the sand and the cement mixed together, is that you have to bite out all the water of both products, because if there's any moisture, you create concrete or you create mortar in your bag, right? So you have a heating process. That heating process, super expensive. The mixing of dry material, super expensive. So you end up with a product that's 10 times as expensive. In the market, that's what we see.
Yeah, you're right, Jamie, with regard to the market. But what we have been doing, and we have been doing some things on a slightly large scale, we have the technology and design tools to use local materials, to make a mix with the grading of particles that you need. And I know if you go to the bags, it's extremely expensive, but you can produce a mortar very similar to what you do with ready mix.
So why would I need a mortar if I have real concrete with, let's say, 8 or 10 millimeter particle size?
Because
I can print taller layers, and taller layers means more productivity, right? We started out with a layer height of 2. The strictly robotic arms are typically at 2 centimeter. We started out at 2 centimeter. We are now at, typically our customers are 4, some are at 5, some are at 8, some are at 10 centimeter. 10 centimeter versus 2 centimeter means finishing 5 times faster. So then that building that was built in 3 days would be built in like 6 hours.
okay,
And you achieve that by particle size. You can't achieve that with mortar.
I don't know about the speed, but from a point of view of savings on material, if you design an optimized element, let's say 8 or 10 millimeters thick, which is a truss type element with mortar, you can save a lot of materials, and that would compensate more for the cement. I haven't looked into the speed of printing. That's something that we
But again,
should be.
10 times as expensive. You have to save 90% of the materials in order to compensate in cost wise. That's the difference between academia and business, right? I have to look at industrial solutions that I can buy anywhere in the world, and that makes economic sense. I cannot use a lot of resources on one particular element with one particular material. I need standardized solutions that I can apply everywhere, and that works for all.
And that's the kind of thing that we are trying to do now in the academia, to develop design tools that you could use locally available materials. And since we are looking about very fine materials, you have a potential of using a lot of recycled materials, which usually are very kind, and they can provide the fillers. And in addition to that, you can look into the new cements, the geopolymers that we have been talking, you have been presenting very nicely, and the magnesium cements, which have superior properties to cement. And again, if you look at a truss type element with a much improved material, well, maybe it's still an academia type research, but I think it has the potential. So
we have done, by the way, also, or we are actually doing right now. We're involved in a project where we are replacing 50% of the aggregates, even up to 100%. But there is actually a negative correlation with the compression phase. if you are using recycled aggregates, we can still achieve 35 MPa compression strengths with 50% reduction, 50% replacement of the aggregates with the recycled aggregates. It simply take concrete, craft it down, and put into concrete again.
But one thing that's I can add to the discussion is what you're looking into truly cleaning is the possibilities, right? Sometimes we need it deep, so when we have the possibility to create concrete, then that is our big car. And sometimes we need to, for some reason, for a special construction, for a special structure, we need to use a specific type of binders. We need much higher durability. We need, for example, much higher thermal resistance for that structure. So that we can use the tree pinning in order to print more fire with more functional material. And one other aspect of 3D printing that is very important is the possibility to selectively deposit the material where you want. Some of our functional materials, for example, now I didn't say any word about it today, but we are developing a specific type of inorganic foam-like material, geopolymer foam. That's they have high thermal efficiency. They are cheap. They can be applied wherever, and using the 3D printing technology, so we can make a truss structure and selectively fill some of the truss with these material. And our recent research showed that we can get much higher thermal efficiency of total building levels by considering the possibility of designing the new material, putting it in the right state.
What's the lowest density you can achieve for foam fibers?
No, I can't say by heart, but
If you can make 100 kilos, I'm really interested.
I think the 300. Yeah,
Not good at it. I want 100 kilos. Because the density is what's called reversely correlated with the insulating capability.
yeah.
So at 100, we get lambda 004, which is what the market requires. But at 300, we get 008 or 0.1, which is not good enough.
But Henrik, one why it is important, for example, by this foam is not combustible. I mean, right, we can use many other solutions.
In theory, has zero CO2 also. Yeah. So zero CO2 achieves and good insulating capability. So do me 100 kilos, then I'm there.
He's working on it. He's working on it. Henrik.
Yeah, I have another question, and something that I don't know. You have discussed the possibility or the impossibility of printing steel. What about using FRP or printing fiber reinforced polymer? Is it? I don't know anything about it, so I'm
Kind of plastic material.
Yeah.
FRP.
Yeah, that's definitely possible. The 3D printing happens with all materials that you can make lowerable first and then will harden up.
Yeah.
Right? In the concrete works by adding water that hydrates afterwards. The metal works by heating it up so that the metal flows, right? The plastic, same thing. Heat it up and then it flows and then it cures afterwards.
Would that be a potential some area to look
I
into?
get that permitted. Good luck. That's the real world, right? Come with a new composite material and try to get that into a building permit. Good luck. It'll take forever.
No. Since we are in the academia, we are not concerned with the building. Sorry, permit. Without the real world, if we were concerned with the building permit, we wouldn't do anything.
You concerned about that?
We actually have a project running with some of your colleagues at PTU, building a robotic setup that is able to print polymers with continuous fiber composites inside of them. It's an ongoing project. It's not finished, but we are getting results, and we are starting to extrude polymers with continuous fiber in buildings.
Dave Bupiers is already doing
Because we see Henrik.
business.
But that would be something that you could have a multi-material type of printing.
In your presentation, Henrik, in one of the videos, we see the 3D printing layer that is actually going on it seems to be a polymer sheet or something. Like we see some kind of a reinforcement that of a sheet. I know that video, by the way, and there is like in between those layers that you are adding some foils or some kind. No.
We do what we call wall ties or wall binders.
Yeah.
So small metal sticks.
Yeah. So it's a metal.
Two parallel walls, right? But
That is to stabilize the layer.
it's simply it's a let's say solution that has been known for making brick houses where you build an inner and outer wall out of brick, and then you connect them with a wall tie so that it will not fall one way or the other. And then the typically the building authorities always say, put in wall ties, like we know from brick.
Raphael.
Raphael Saxon from the Technion too. My work is in building information modeling and digital twins. I'm really curious about your comment about the operators and their skill. One would think that with a very minimal amount of sensing equipment, you might be able to monitor the actions of the machines as it's running and but augment the operator with digital twin predictive equipment and software that might improve that. In other words, make the system reliable without a highly skilled operator, or at least reduce their dependence on the skill of the operator.
Let me give you a small example. If your recipe requires that you take in a certain amount of material, and then the materials operator loads a wrong amount of material, it's difficult to compensate for that things. Obviously, now we made a solution so that as long as the material operator fills up the bins, then the machine automatically takes the right amount, right? Yeah. But there are issues like this that you need to react when the torque of the pump is going up and so. But I agree, to a certain extent we can automate it. We can put sensors on. It would just take time. There's a lot of innovation as this.
Yeah.
You showed once a video, not today, about your printer in India.
Yeah.
And there were tons of people around, 100 probably, right?
That's crazy.
Yeah. What is the issues with human-machine interactions? Like even metal printing, how much do you foresee in the future? And how could that be in?
Well, to us, it's been a big surprise that we could sell printers in Africa and India, right? Because our solutions was made to combat the high cost of construction caused by labor costs, right? And in Africa and India, they buy a printer and then they have 20 people around it. The same printer requires 3 or 4 persons from anywhere in Europe or in the US. It's in Africa, it's the skill. Basically, they have too few skilled people, and now the printer has the skill, and then speed of execution and skill. And in India is it's probably also that because the people are so cheap. We also see that in the Middle East, because people are so cheap, they don't care. They just take, let's just take not 8 or not that. Yeah, okay. You say, no, I think you need a little more. Okay, let's take 50. Forget.
Even metal printing, it takes a lot of skills, right, to operate. Yes, it does. And this, you were asking about safety issues as well. Depending on which technology you use, if it is the simple welding done, there's not that much in terms of safety. There's the regular robot safety. If you're using the laser technology, it's a kilowatt laser. So it's several kilowatts, probably up to 6 kilowatts or so. So any stray radiation and you'll go blind immediately and you will never recover your eyesight. It's just a permanent thing. So these things need to be encapsulated in some way. So if you're printing metals, it's usually inside of a sealed cabinet of sorts. But the safety distances will be up to several hundred meters.
The bridge was built on site, no? It was actually not built on site. It was built in a lab environment.
Okay, and when it was not big, it was built with traditional welding guns. It was announced in the 18, and I think it was built in 22. It took 4 years.
took 4 years to complete. Yeah.
Can I say something on the business side? It seems like you mentioned the investment in research and development being large, but compared to everything else, it's probably a drop in the bucket, right?
Yeah. I'm just
So the industry is changing too slow. What's really needed? I mean, is it the owners of buildings who jump on it? Is it the builders? I mean, this transition has to happen, right? Eventually.
It happens slowly but steadily. And we can speed it up by making the technology better and so on. But
Or will it go the regular way of innovation? It takes 20, 30 years.
Yes.
And then, okay, you think like that? Yeah. I do. Okay.
of course,
Yeah, because you didn't provide you with holiday. So you
I can go on.
Sorry.
Yeah, I can hear that.
okay.
Ekaterina Petrova from TV Eindhoven.
Yeah.
Sorry. Yeah, I didn't hear before. Sorry, Katerina.
You showed in your presentation this move to integrate so the 3D printer with the rover. And I wonder from an innovation perspective, how long are those cycles? Because I imagine that at some point, so from the realization that you need that equipment integration until that being on site, you are racing time. So how long are those cycles?
Yeah, it's almost embarrassing. I got the ideas for this that I showed back in 19 and 20, but it took that long time before we actually realized it. As a combination of that, we have to live. We are a for-profit business, and so quite often, customer projects came in the way. That, for instance, they wanted the Excel printer, so we had to spend time on developing that, and other stuff like that. So the whole thing just got very delayed. Now we have the fundamentals. We actually built 3 of our own robotic arms for different payloads and reach and so on. And so I think the coming years will be very exciting because we will figure out how to use these for more and more functions. That I don't have the solution for now, but I think in that direction we can do something, right? Painting and plastering and grinding and even drilling, whatever.
But do you foresee, let's say, simply adding complexity to that integration, or more adding separate agents with different capability over together?
The thinking behind this is that we had all this trouble of putting up the printer, right? Like it takes a day or something, right? But this is where it got crazy for me, because you're printing faster and faster, 24 hours for that build. I can guarantee you, if we set our mind to it, we could do it in 1 day now. So it takes a day to set up the printer, and then it takes the day to print the building, and then it takes half the day to take the printer down. Hey, that doesn't make sense, right? That the setup time which is up is. So I thought, well, let's get more out of that. We spent the time on setting up the printer, which is why I added things to the printer as a combined system rather than independent system, right? And the other realization, this realization also led to the Pod 3, the one on tracks, because there you have 0 setup time, right? As soon as you've installed it once for 20 houses in a row, takes a day, but then you have like half an hour setup time every time, right? So.
Need a final one, if I may, in that regard, in this regard. So is high-rise them completely out of the question? And by high-rise, I mean really high-rise.
Yeah, we are involved in one project now, where the principle of that project maybe could be used for doing a high-rise later. So it's a data center. Everybody's building data centers and investing like crazy. And we are, of course, have invented a method to build it faster, construct them faster. So this is a data center which is 18 meters tall. It's very long. So 18 meters tall normally speak for that we should use the XL printer, the gantry type printer with 4 legs and 6 and 8 legs if you make it longer. We are very up, and it's like 100 meters long, right? One printer. And, we saw the 2 others, they were pretty big. And then up in 18 meters. So we had that warehouse printer that I showed over on the right-hand side that I didn't show the details of. So the idea could be, okay, let's print the first floors with that, Then let's cast a slab, and then let's put it inside the slab, and then print the walls from the inside. Right? So maybe that principle of lifting the printer beneath floor, maybe. It's not something that is really high on my agenda or wish list because the market for high risers is limited still. You know, most cities like Copenhagen have a limit on, you know, you can build 5 floors, that's it. Because we don't want to have all these high rises, then single buildings are then allowed. But overall, the market for high rises is pretty small.
One follow-up question, Lucia, from you, Ulik. That, for example, the wind turbines are kind of high-rise, right? So how do you...
There we are developing, this is crazy. We are really gone crazy this time. I don't know, man. We are developing a new printer, a tower printer, 80 meters tall. We will have one structure going up 80 meters a year.
Everything's assembled in once, or
It's by component, by modules, right? And then it's a centerpiece. So it's a centerpiece where you have an arm like that, a big arm like that goes like that, because you know it's very easy to just go around these window towers. So you install the arm at the bottom, but these, of course, sections, you know, 10-meter sections on top of each other, you need a crane for, right?
Yeah.
But the idea that it will stand do you realize how much 80 meters is? It's really crazy. If you know the round tower here in Copenhagen is 2.5 times the height of the round tower. It's really, really tall.
and then you also can close it because you have to take
Yeah.
everything out.
Yeah.
Yes, and then
No, because I stand next to the tower. I don't sit within the tower.
oh, okay.
I print next to it. So yeah. I don't know if we matters because 80 meters is just the wind load up there. Easy. Yeah, there's a lot of challenge in it. So you see, we are not scared, right? We are not. We do dare to very innovative things.
Steel printing must be part of that then.
Sorry.
Steel printing. Printing. Just to get stiffness, maybe.
Yeah, but that I can't wait. You know, he'll be finished in a month or so. I need to be finished in a day. So sorry.
I have a question. We're soon gonna wrap up the session, but my name is Anat. I've been in touch with you via email from the Technion. Thinking about innovation more in regards to knowledge exchange and perhaps education and training. And I think for you, Michel, that's something that you're kind of between the academy and the industry. But what are the needs and the focus and the dedication that is existing as far as really kind of focusing on that aspect? Like what kind of training, how are researchers or students or young or like upcoming employees, how much is around that, and what are some of the methodologies, and if you can expand on that. And maybe I'll just contextualize that. As part of AM2PM, we're having a living lab, which is a way to disseminate knowledge, both with students, researchers, within the consortium and partners from the industry. So that's kind of like part of the question, basically.
So if I may, I think the biggest that we see in education is that the free printing and additive methods are not taught as part of the toolbox that the candidates come out with. So when they design stuff, it's always designed for traditional manufacturing methods. And that would probably be using slabs or concrete walls or whatever in buildings, and in metals, it's machining in CNC and stuff like that. So they do what they've always done. That's the toolbox they bring now. So when you go out and design something, it should be designed for 3D printing, either whether it's a house or a machine component or whatever it is. You don't take an existing design and convert it. It's almost always a bad idea. So you could design for 3D printing from the very beginning. That way you can make something that makes sense to print, but don't think that you can take your existing design and then print it, because that was made for building bricks or sushi.
So it's kind of like the interrelations between the architect and the engineer, or that's the missing.
It's a matter of thinking of the method from the beginning. So make sure you don't design everything with old tools like ruler and scale and whatever, but do it with 3D printing in mind if you want 3D print.
But this is also a concept of our section, into construct digital building technology. That we are trying to embed deep kind of interdisciplinary knowledge for our research and education, for our master student, bachelor student in the thesis, not in the context level courses, but in the thesis. They come from our lab, they understand how to design the materials, how to use the 3D printers, how to use the vision technology, to see what are the possibilities. And most of the time they come, it's totally innovative ideas. That's sometimes it works because we, in our education, we used to think in a very fundamental way. But when they are educated in a very early stage of the career to look at things from different angles, then they most of the time come with a fully new solution. And these sometimes work, sometimes doesn't work.
To learn more, visit am2pm-project.eu and follow for updates.